All right. The second type of isomerism we have is geometric isomerism. Geometric. All right. It's a form of isomerism which exists between compounds with the same structural formula arising because of their relative inability to rotate about a double bond or a ring structure. What does that tell you? Okay, compounds having the same structural formula. Why do they have the same structural formula? Because of their inability to rotate by reason of the presence of a double bond between them. Can you see? That is why the structural formulas of both of them, of the compounds, are the same. Can you see now? The molecular formula the same. The molecular formula, okay, different. Why the structural formula is the same? Why? Because of their inability to rotate around the double bond. Look at the first example you have there. Trans 1,2-dichloroethene. Why is it trans? Trans is like talking of like vertical, sorry, like transverse. If you know what a transversal line means, transverse. Look at where the CL is. Look at where the CL is on the first one. While on the right hand side, look at where the CL is. So when the CL, they are both below, that one becomes cis 1,2-dichloroethene. If they are like in the form of slant form, that one is trans and cis. All right, those are the type. Those are groupings under geometrical isomerism. Look at the number 2, the same thing, trans. Look at it. Look at the attachment CH3, like slanted. They are aligned in a slant form. That one is trans. Boot 2 in. The other one is cis. They are either up. When the attachments are on an horizontal position, either upward or downward, that is a cis kind of geometrical isomerism. Then the third one quickly is optical isomerism. Optical isomerism. It's a form of isomerism in which the compounds with the same molecular formula assumes different configurations when encountered by light. So the key word here in this kind of isomerism is light, and they are able to rotate plane polarized light either towards the right. When they are able to rotate plane polarized right, when they are able to rotate plane polarized light towards the right, that becomes a dextrorotatory optical isomerism. And when it's towards the left, it's called a laboratory optical isomerism. Let's take note of what I'll be writing. Jamb and post-UME may encounter stuff like this. Let's take note. All right. For example, the lactic acid can rotate to the left. Can you see? Look at the first diagram on the left. Look at the second one on the right. Once you place it, when it encounters light, it rotates to the left. So that kind of lactic acid undergoes what I call laboratory optical isomerism. Let's take note. This will be of huge help to us. All right, quickly, calculation of isomers. All right, so if you look at the table, all right, look at the table. Number of isomers for the first 20 members of the alkane family. So look at that. You can study the table. You want to memorize it, no problem. Methane has 1, ethane has 1, propane has 1, butane 2, pentane 3, and all that. All right. Now test for class of hydrocarbon. Number 1, test for unsaturation. How do we test for unsaturation in an organic compound? All right. Unsaturated compounds such as alkenes and alkynes, they decolorize bromine or bromine water. This is another Jamb question. They decolorize bromine or bromine water on mixing together, but alkenes do not. This is test for unsaturation. Pardon me. Alkenes do not decolorize bromine or bromine water. Only alkenes and alkynes do so. The second one, unsaturated hydrocarbons such as alkenes and alkynes, they decolorize the purple color of acidified potassium tetraoxomanganate 7, KMNO4. KMNO4 is purple. When you react it with an alkene or an alkyne, the KMNO4 is now decolorized to colorless. It becomes the purple color of the KMNO4 disappears and it becomes colorless. All right. So alkenes and alkynes, they decolorize a potassium tetraozomanganate 7 solution. Alkanes do not decolorize KMNO4 because they are saturated. Now, how do we distinguish between ethene and ethyne, between an alkene and an alkyne? How do we distinguish between them? All right, when each of them is passed through an aqueous ammoniacal solution of copper 1 chloride or silver 1 chloride at room temperature, ethyne produces a reddish brown precipitate. Ethyne produces a reddish brown precipitate of copper 1 acetylide, or silver 1 acetylide, while ethane shows no reaction. I think that's a mistake. There should be ethene, while ethene shows no reaction. I think that's a mistake in the typing. Why ethene shows no reaction. So that's the difference to distinguish between an ethene and an ethyne. When you pass both of them into a solution of copper 1 chloride, ammoniacal copper 1 chloride, or ammoniacal silver 1 chloride at room temperature, ethyne will always produce a reddish brown precipitate, while ethene will not. All right, the last note on this class for today, I think next class we're going to be going into alkanoic acids and naming of organic compounds. Alkanoic acids, and the naming of organic compounds. All right. So formation of crude oil, we can go through these notes. I've already explained. I've done justice to most of the notes here. Refining of petroleum, I've done all that. What I want us to focus more on now is that table below. Let's look at the table below. All right, look at the table below. Look at it. Fractions from crude and their boiling point ranges. Why did I want us to look at this? Because I think I've seen some Jamb questions coming from this table. Natural gas, okay, from C1 to C4, natural gas. The boiling point is less than 20. They are used as industrial and domestic fuel. Jamb asks this question virtually almost all the time. Which of the following hydrocarbon is used as industrial and domestic fuel? All right, natural gas. Then ether, petroleum ether, naphtha, gasoline. They are used as organic solvents and fuel for vehicles and solvents for paint and grease. Kerosene is used for lighting and heating and fuel for jet engine. Yes, very important. Then gas oils and diesel oils are used as raw materials for the cracking process, while lubricating oils are used for road construction. So I'll send some other questions, Jamb questions. Every question I send on the group, let's try and attempt them. They are Jamb questions. Our aim is Jamb questions, and they're also beneficial to Waec students, also students writing Waec in the group. Thank you very much. I'll send the questions to the group.